What's up, guys? So today what we're going to do is we're going to take a look at some simple machine learning and how it applies to stock predictions. I'm not saying the accuracy is going to be great, but let's start somewhere and try and get everybody rich, okay? We got to start somewhere. So the premise is we're going to use Apple's stock because it's got a lot of data, it's widely available. We're going to train a very simplistic one feature, one time step forward model using linear regression. And I don't expect very high accuracy, but at least we'll know. We'll see how to use it in a very simple way, and we can kind of expand it into an overall trading strategy from there. Although I'm not going to go much into the trading strategy stuff. Because this is daily values, it's probably more akin to swing trading. So you'll probably have to apply your own algorithm past that, and then in later episodes we'll be looking at more advanced techniques to bring in the amount of deviation to an acceptable level. So let's jump into it. So the first thing we want to take a look at is just installing the common libraries that we need. So you see we're using the Alpaca Trading API. So this is a broker. They provide very simplistic APIs for actually doing any of the trades or getting positions and some more simplistic information. They take a percentage of the actual conversions, so the cost if you're keeping it in US dollars or your stocks are in the same currency that you're making the purchase in is almost nothing. And they're well funded as of November. So the next one is scikit-learn. So this is the actual core machine learning library. This has a number of more simplistic models. I'm not sure if you can do layering in here. I haven't seen that yet, but it does have the linear and logistical regressions. For our particular case, because it's not a classification problem, we'll be using the linear regression. Next is pandas, and pandas, as many people should know in the data science world, is just the common library for storing the variables and doing any manipulations on it. And the next is matplot, which is just a standard package for actually plotting or graphing the information, which is useful in data analysis and reviewing the actual predictions. So we can see it's done the installation, so let's just keep going from there. So next part is we're actually using some named functions here. So I wanted to load those up, and we'll actually explain these kind of as we're going. But it's important to see kind of where they come from up here and which libraries they're from. So we'll just load those up. You can see for the scikit-learn, we're taking the pipeline because we're actually going to be using a pipeline approach instead of doing any manual scaling that might be needed. And then training a linear regression model. And within that pipeline, we'll be using the actual standard scaler to bring all the data to between 0 and 1 so that the actual model training doesn't have to do that itself. So now we've gone ahead and actually loaded the data here. There's a GitHub repo you can check down in the comments that has all the actual data in the actual Jupyter Notebook or Colab Notebook if you ever want to try this yourself. So we've loaded the data now, and then we can take a look at the data. What we want to check here is just if there's any abnormalities, missing data that we might need to fill in, or if we were doing multi-feature, we may need to look at how to divide up the actual scaling. In this particular case, volume is so far different than adjusted close and open values that if you try to scale those together, it would not show up with anything great. So we'll just plot it so we can take a look at the actual data we're using for training. Now typically in training data, what I would like to see is more reoccurrences so that the training data can kind of see that. We can see in the data like there's a large drop off at the end that doesn't really occur in the other data. So this might be hard to see that when you're actually training it and may not show up in previous prediction models. But again, this is a one feature, one time step ahead, so I'm not expecting great accuracy here, but it's a start and we're trying to get everybody rich. So let's just go from there. So the next section, we're actually loading the data. We're going to shift the 1 by 10 just so we can have a comparison piece. And then we're going to be splitting it into the train test splits in order to do the training and the testing of the models. So we'll just run that. It just uses the scikit-learn libraries to do that for us. And here's those pipelines we discussed earlier. So again, we're using one feature, which is the adjusted close. And because of that, all the numbers are within this same kind of like value range. And we can use a standard scaler in the pipeline and then feed it into a linear regression model, slowly trying to weed out kind of the deviation for each time step. So we'll just go ahead and do that. It's pretty quick. And then we're going to get an idea here using the k-fold and the cross-validation score of kind of how well we could do. We'll just take a look at that score. So we'll see it depends definitely here on the train test split. The last time I ran this, it was around 43. Now it's 41, so it's a bit better. So now we're just training. We're actually going to do all the predictions against this particular test split. And we're going to plot that data to see how well it does. So we can see in some of the cases here, it can be quite far off. So we'll take a look at that and quantify it more because we want to know how accurate we are. So this just shows how to make kind of one prediction. We can see we've done one prediction, it's gone one time step in the future, and it's deviated slightly. And so here we're testing against the actual back test, which is also in the repo. So we'll just go ahead and load that up so we can get, this gives us a more accurate view of how the data does. So now we're going to run this and get the actual average error, so for our particular case, we didn't get quite as close as the expected, but we're pretty close. The only problem here is a 43 variance on a stock that's around 200 is nowhere near good enough accuracy to be making predictions on. And we can see there's also a max variance, which is like significantly higher in my opinion. I think about 10%. And so this kind of gives us an indication this probably isn't usable. The accuracy isn't high enough. Sitting around maybe 30 to 40% deviation is not really usable. The gold standards that I've seen are around 3%, but let's start with just learning these machine learning models and how to integrate them into an overall stock trading bot or mechanism. Typically, what we would do here is actually take the training predictions, if they are accurate enough, and then use the Alpaca API to make the actual predictions usable into trades. So we would get our current positions, run any models we want to know against that, and decide against any new purchases or sales that we want to make based on the prediction data. For our purposes, we want to learn the machine learning, so I'm not going to go too far deep into that, but you can see kind of the basics of how we'll get there. In the next episode, what we're going to do is we're going to take a look at some more advanced machine learning mechanisms, what their accuracy are, and how we can use those, possibly if they get accurate enough, into a full trading mechanism. But for now, this gives you a good introduction of what simplistic machine learning can do, how it relates to stock trading, and we can keep learning more to start getting everybody rich.